Okay, so in the last video we got the basis for our reflection pass in place, but we don't yet have the ability to specify the blurriness of our reflections. That's what we're going to tackle in this video, and it's actually going to be really simple. If we take a look at our shader, down in our shader, we currently, in our environment map reflections, we simply are hard coding in which HDRI we're using. Instead of doing this, we create a number of parameters, each parameter pointing at a different convolution of our HDRI, and then we switch between those parameters based on a reflection blurriness parameter. We can then specify up on our asset how blurry we want our reflections to be. So to start out, I'm going to give myself plenty of room. So I'm going to move the Fresnel VOP out of the way, move our environment map over here, because I know I'm going to have a large list of parameters getting created. Just drop this down out of the way of everything else. Fantastic. I'm going to start out by middle mousing on the env map input of our environment map reflections and creating a parameter node. Now you'll notice by default this has taken our crisp reflection map, our original reflection map, because that's what we set on our environment map VOP. So that's going to be the current image specified on this parameter VOP. And since that is the current image, I'm going to say that this is our 0% blurriness reflection map. So that's reflection map underscore 000 blur. I want to grab the name of the node, use that as the parameter name, and let's give this the parameter label of reflection map 0% blur. Now that we have this, I want to copy and paste this parameter VOP and set it up for 10% blur, 20% blur, all the way through to 100% blur, obviously updating the name of the VOP, the parameter name, the parameter label, and the image we're looking at. After the first couple, you'll probably get the idea of what we're doing, and you'll probably want to go ahead and just do that on your own and then fast forward the video. I'm going to do them all on camera, but it is going to get a bit repetitive. So let's copy and paste this node, and this is going to become our reflection map for 10% blur. So that's going to be the name of the parameter, and that is going to be the label of the parameter, 10% blur. And our 10% blur is our convolution 800. Recalling again, the lower the convolution number, the more blurry, the closer to diffuse our environment map has been processed, if you will. So 256 original is the most crisp, the least blurry, all the way down to convolution 1 being the most blurry. So our 10% is 800. If we accept that, then copy and paste. Let's repeat this, undo. I did not want to input it in that particular wire there. This is our 20% blur. That's going to be 400. Copy and paste. This is our 30% blur. And this is going to be 200. Copy and paste. This will be our 40% blur. Which will be 100. Copy and paste. Let's make our 50% blur. That'll be 50. Copy and paste. 60% blur. That's 20. It's worth pointing out the values that I used when processing the convolutions and the subsequent numbers that are in those maps were the values that I used in HDR Shop for calculating the convolutions. These aren't really scientific values. These were just values that I was plugging in that were giving me what I felt were a nice range of reflections between having fully crisp reflections and having completely diffuse, very blurry reflections. So I just went in and I chose some numbers that I felt were giving me nice, fairly even steps between fully crisp and fully blurry. I then just used the numbers that I'd input into the convolution algorithm as part of the file name, just to help me in case I decided I wanted a image that was partway between, say, 5 and 10. I knew then if I jumped over to HDR Shop and blurred our original image and I gave it some value between 5 and 10, that I'd be dealing with a value that should give us an image that's blurriness is between the 5 and 10 images. So here we go with 100% blur. And that is going to be our diffuse convolution. So now that we have all of these, I'm going to right click on the output of our original and create a switch VOP. Obviously it's going to wire the input in incorrectly, but the nice thing is it gives us a switch VOP, the output being wired into our environment map. And this switch VOP is going to be our switch underscore reflection convolutions. And I want to wire each of these in turn so that input 1 takes our least blurry, and as we go through an increase in inputs, we're going up to the most blurry so that the parameter that drives this can have an increasing integer value, and the larger the integer value, the more blurry the reflection. So I'm going to start out by selecting 0 blur, and then I'm going to shift select in turn each of the blurs going up in terms of their blurriness value. And then if I take the output of these and wire them into the input, you'll see that these have been wired in order going from least to most blurry as we work our way down. And we can see we need a value that ranges from 0 up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a 0 through 10 integer value. So we can create a parameter that will control that value, and that will be our reflection blurriness. So let's give that the parameter name, reflection blurriness, and let's give that the parameter label, reflection blurriness. And I am going to leave this just as an integer, and it is going to range between 0 and 10. Now the interesting thing here is that we could perform, fairly complicated calculations whereby we take in a percentage value from 0 to 100% and we use that to work out which input we want to switch between. But really, that's kind of more work than we need to be doing, and there's a couple of reasons that I feel that's the case. Firstly, we would have to perform quite complicated calculations in order to work out that value, and we don't really want to be doing that in our shader. It's just going to slow us down at render time. But secondly, it kind of misleads the artist into thinking that there is this nice floating point range, if you will, of blurriness values from 0% through to 100%. By presenting them with a reflection blurriness parameter that is using integer values, that means that we are presenting them with the knowledge that they're dealing with discrete states. That is, there is no in-between between our 0 and 10% blur. It is one state or the other state. We're using one or the other environment map. So by presenting them with this particular scenario, we know that they are dealing with discrete states, which means that they're not going to spend their time going, oh, I don't know if I want to use 15% or 16% blur, where under the hood all that's doing is selecting the same environment map the entire time. And it also saves us from having to perform a number of calculations in our shader that we simply don't need to be performing at render time. So that's all of the changes to our shader. We do need to promote up some of these parameters to our asset. So let's bring up the type properties of our asset. In the technical setup folder, I want to create a separator underneath our diffuse environment. And then from nodes, I'm going to make sure we're not prefixing anything. We've got our reflection map 0% through to 100%. They are, again, various paths to our HDRIs. They need to go into our technical setup folder. So let's promote those. And I want to make sure that they are beneath our separator. So if I was to apply and minimize, bring up the parameters, you can see that we have our diffuse environment and then we have our various reflection maps. Fantastic. And then we also want to promote up the reflection blurriness value. So I'm going to grab the reflection blurriness parameter, and that's going to be put on our shader. And where on our shader? Well, let's create a new folder for reflections, which I'm going to put in brackets specular, just so that someone who's using our shader, who doesn't necessarily know that we're dealing with reflections basically representing or even replacing, if you will, specular highlights, they could see a diffusing specular and have an idea that you're dealing with a diffuse component and a specular component, whereas diffusing reflections might not necessarily, to an artist using our shader, they might not necessarily be as clear as they need to be. And I want to take this reflection blurriness and put that under the reflections folder. I do want to also make sure that we lock this between 0 and 10, giving us that full range of 0 through to our completely blurry map without being able to go beyond that point. So if we accept that, and we're to now jump up and look at our asset, we can see that we do now have this reflections folder with the reflection blurriness. And let me just tear off a copy of this. There we go. And if I was to jump to our output context, we could go ahead and we could render some various passes and take a look at how reflection blurriness is affecting things. So let's start out with very blurry reflections and then work our way back down to crisp reflections. So I'm going to render. Let's bring up the task manager so we can see what's going on. So there's mantra. Just give that a second to render. It's a fairly quick pass to render because we're simply doing a very simple algorithm where we're reflecting a vector based on a normal and then we're using that as a lookup. Let's also tear off a copy of this. Fantastic, just so I can quickly re-render. And now we can jump over to our composite view. Take a look at the compositing network. You have to forgive the fact that I'm dealing with a very low resolution here and it's quite restricting in terms of what we can see. If we reload that, these are our really blurry reflections. Now, it's to be expected that these reflections are incredibly overblown in terms of overexposure, because if we think about it, a surface that's very rough, that is scattering the reflections by a large amount, really should have a higher diffuse contribution than the specular contribution, which would mean that our specular would really be a very dull highlight on the top. You know, something very, very low. We do have the ability, if we wanted to make this really high, to create some weird shaders, or sometimes to create surfaces that don't necessarily respond in terms of our sort of logical understanding of all the surface is rough, therefore it should have a higher diffuse component, because there are some sort of polished metals, or rather than polished metals, they're kind of, they've been rubbed down so that they've got a very rough surface, but they're still a metal, so they still have a very high reflection component to them, but that reflection component is heavily blurred. So it's sometimes useful to be able to have very blurred reflections, but push the reflection amount higher. So by specifying it separate from our reflection amount, it just enables us to be able to fully customize the looks of our shader. So that's our fully blurry. And then we can bring this down. I guess let's choose 6 and re-render. So there's mantra. Fantastic. Let's reload this. So now we can see these are slightly less blurry. Bring this down again and re-render. Just give this a second to render. So see, on the whole, it's not a very slow pass to render. So slightly less blurry again, and back down to perfectly crisp. And that's the nice thing of using this environment map based lookup as opposed to using ray tracing. It's a very, very quick render to perform. So there's very crisp, taking us back down to where we were before. So now with a very simple single parameter on our shader, we have the ability to specify how blurry the reflections are, and later on when we deal with balancing the diffuse and reflections component, the combination of that reflection amount with how blurry the reflections are, it's going to give us such a huge range of control over surface properties that we're going to be able to define a huge amount of different surface types, and that's very, very powerful and very useful to us. So that is going to conclude the reflection blurriness parameter of our shader. Thanks a lot, everyone.